Hello everyone, welcome. My name is Tommy, and today we are diving headfirst into the world of ICT, information and communication technology. So, whether you are thinking about enrolling in an ICT course or currently drowning in network diagrams or just wondering if this field is actually worth your time, I've got you covered in this video. We are breaking down exactly what to expect, what you'll actually learn. So let's get into it together. Before we even open the notes, quick question. Your phone runs out of battery power and turns off completely. You charge it back up and turn it on. Or if your phone freezes and you force restart it, uh, your contacts are still there, your images and videos are still there, but sometimes an app you are using loses everything you typed. They're all stored in the phone's memory. So why does one kind of memory survive a power off and the other does not? So that question is actually the difference between two types of memory, two types of computer memory, which we'll get into in a later video. That's what this topic is really about, not just memorizing definitions, but understanding why computers are built the way they are. So in this video, we are covering the foundation, the key terms you'll see over and over this course, then why computers matter enough that almost every organization today depends on them, plus a fair look at their downsides. So let's get into it. Here is how we will move through it. First is the vocabulary, which is the terms. So don't you worry, they build on each other, so you don't feel it will not feel like a random list. Then you have the advantages and disadvantages of using computers. We have the concept and explanation of ICT. So by the end, you must be able to explain these words in your own explain these in your own words, not just recite the notes. So let's start with the obvious one. What is a computer? So a computer is an electronic device that accepts input, processes it, and using a set of instructions, which we call software, and then stores. So it processes and then stores and then produces output. So notice the sequence. We have input, process, and output. So no matter what you're doing, the process is always similar. So that's the heartbeat of every computer. So from the laptop that you're using in front of you to the ATM that you withdraw cash. So physically, when we say computer, we usually mean the central processing unit. So this box that we have here, so that's the CPU, or the central processing unit. Then we have others. We have the monitor, we have the keyboard, and we have the mouse down there. Yes, so everything else that connects to into it. We have other ones that are not there. We have the printer, we can have a flash disk, we can have a webcam. So all those, we call them peripherals or peripheral devices, which we will define properly in a minute. So next we have computing. So historically, computing used to be defined as the act of calculating. It can be adding, can be multiplying, or basically running calculations which are performed by humans, often mathematicians of those times. So computers got their name exactly from this, because they could compute faster than any other person could by hand. So over time, as mechanical and electronic machines evolved to perform these exact tasks, the term transferred to the use, study, and engineering of computers. So when someone says cloud computing or quantum computing, they are really just describing different ways of doing calculations at that specific scale. So we have a diagram here, a quantum computer diagram. So this part at the top here, this is a diagram for classical computers that we have, which we says it is always similar. It follows a procedure of input, process, and output. Then we have an added technology, which is the quantum technology, to the classic computers. So now it is now referred to as the quantum computers or quantum computing. But we shall define that in another video. We shall go into quantum computing. Same with cloud computing. We have your storage, we have your mobile, your applications. So basically everything is done on the cloud. So that becomes cloud computing. Also, we shall describe it more in a later video. Now here is a pair of information that we will be mentioning a lot throughout the course. We have hardware and software. So we'll start with the hardware, the computer hardware. So it is anything physical, anything you can touch, which is the monitor, the keyboard, the mouse. So we have monitor here, keyboard here, or can even be internally inside the computer, things like the motherboard. That we have other things like hard drives, the computer memories, all those. As long as you can touch, it is hardware. Then the software is the opposite. It's intangible. Set of instructions tell what that hardware to do, tells the hardware what to do. Think of it this way: the hardware is the body, software is the mind. So giving it instructions. For example, we have the Office applications, Microsoft Office applications that we commonly use. We have the Word, Excel, PowerPoint, all those. We use them to type documents most of the time. So another example is your phone. Your phone screen is the hardware. The WhatsApp app running on it is the software. So basically, if you can drop it on the floor, it's hardware. If you can only see it on a screen, it's software. An electronic device, more broadly, is any system that uses electrical signals or electricity or current flowing through circuits to perform its operations. Yeah. So I think we have mentioned also mechanical devices which use physical force for them to work, but we shall talk about mechanical devices again in another video. So a computer is one example of an electronic device. So is a calculator, so a radio, and a digital watch. So not every electronic device is a computer, but every computer is an electronic device. This next pair is one of the most commonly tested definitions in this course. We have data versus information. So data is raw, unorganized, and formatted facts. On their own, they do not have much meaning. Think of a column of numbers. We have a column of numbers here. That is 45, 67, 29. So that's data. So information is data that has now been processed into something meaningful and useful. Now, if I tell you those numbers, what exam scores for 4 named students. So we have the data here, and now we have the information there, sorted from the highest to the lowest. Now it's information. So same numbers, but now they mean something to you. So data in, information out. So that's what a computer does every time you use it. Computer memory is the storage location of data, information, and instructions inside a computer. We'll get we'll go much deeper into the specific memories. We have random access memory, read-only memory in a later video. You can look at what they are. So for now, just hold on to this. So memory is where the computer keeps things, whether temporarily or permanently, while it works. A peripheral device is any external or internal hardware component that connects to a computer to expand what it can do, or we say expand its functionality. It can be an input device like a keyboard or a mouse. We have an output device like a monitor or a printer, or storage devices like the USB. We have external drives here, we have USBs here. Yes. Basically, it's not the core part of the CPU, the box I mentioned earlier. So it plugs into and add a function. That's why it's called a peripheral. A program is a set of instructions written in a programming language. So we will talk about programming languages. There are many programming languages. We'll talk about them in a later video. So set of instructions written in programming language that tells a computer how to perform specific tasks. So programs can range to something as simple as a calculator application that you use on your mobile phone or on the computer, to something complex as an entire operating system, which you can install programs into it. So the CPU works together with other hardware to run programs, process data, automate tasks, and give you functionality you actually use. So programs are the foundation of everything that we call software. Finally, a computer system is the combination of hardware, software, peripherals working together to process data and perform specific tasks. It includes the physical parts, CPU, memory, storage, input and output devices, and the software layer. So the software layer is now the operating system, the applications that you use, whether it is the WhatsApp, the Office applications, all following instructions to let you browse, run programs, and manage files. Now back to the smartphone question from earlier. So is a smartphone a computer? So walk through it. Does it accept input? Yes. Your touch, your voice input. Does it process that input using software? Yes, it does. So processes it, whether it is application you want to open, you touch the screen and the application opens. So that is a method of input, processing, and output. So yes, so by our definition, yes, a smartphone absolutely qualifies as a computer, even though we don't usually picture it in that way. So let's quickly recap before we move on. We talked about computing, the hardware, the software, electronic device, data, information, memory, the peripheral devices, programs, and the computer system. So those are 11 terms, and notice how they connect. A computer system is made of hardware and software. Software is made out of programs. A program processes data into information, and memory and peripherals support the whole thing. So it's not 11 random definitions, it's a connected picture. Now that we know what a computer is, let's ask a practical question. Why has almost every serious organization adopted them? So there are 8 advantages worth knowing. First is the speed of operation. So computers process data at extremely high speeds. Think of like the KRA iTax system processing thousands of tax returns during a filing season. That work will take a lot of clerks weeks processing that by hand, which happens in hours. Second, we have accuracy. So in accuracy, we have a condition attached. So computers are precise as long as they are fed correct data and instructions. So memorize this exact phrase. We have garbage in, garbage out. Computer will not fix bad input. It will just process the mistake accurately. So that's point to note. Third, we have employment. So computers have created entire job categories that didn't exist a few decades ago. We have IT support, software development, data entry, and cybersecurity. Fourth, we have security itself. So computers protect data through passwords and biometric scanners like fingerprints. We have facial recognitions on limiting who can access sensitive information. So think of how your mobile banking app requires a PIN or fingerprint before you can do any transaction. Fifth, we have the cost reduction. So by automating tasks, computers reduce the need for manual labor. Work that once required many clerks can now be handled by one person. Operating system, for example, a single cashier managing an entire supermarket stock digitally. Sixth, we have consistency. Give a computer the same input and the same process. It will always produce the same results. So there are no fatigues, there is no mood, there is no shortcuts. So every single time it will always produce the same process, which a human cannot. Seventh, we have the storage. Computers can hold huge amounts of data and retrieve it quickly whenever needed. A single hard drive today can store what you used to require rooms full of paper files. And lastly, computers can work in an environment in environments hazardous to human health. Robots used in chemical manufacturing plants or drones inspecting damaged structures do jobs that are too dangerous for people to do directly. Every technology has trade-offs, so the computer has no exception. 4 disadvantages are worth knowing. First, we have the job replacement. So as computerized systems take our tasks, many employees have lost their jobs that used to require manual effort. So automated tellers, we have online banking have reduced the need for many banking staff. Second, and this is different from job replacement, so do not mix them up. So that is job displacement. Here an employee isn't let go but is moved to another department, so either because a computer system took over the job, the original role, or they lack the computer literacy for the new system. Third, we have high costs. So computers are expensive to buy and expensive to maintain. We have the hardware upgrades, software licenses, the IT support stuff all add up over time. Fourth, we met this term already as part of accuracy, but it's also listed as a disadvantage. We have garbage in, garbage out. So feed the computer incorrect data or instructions, and it will confidently give you wrong results. So the computer does not know the difference between right and wrong data. It trusts what it's given. So job replacement, job displacement, high costs, and garbage in, garbage out, 4 honest trade-offs alongside those 8 advantages. And there are other disadvantages as well. of which I will give you as an assignment. So go find 4 advantages of using a computer. So previously we built up to one big idea, piece by piece. Hardware plus software plus peripherals equals a computer system. But here is the thing. A computer sitting alone on a desk, cut off from everything else, is only half of the story. So what happens when a computer system starts talking to each other across the room, across the city, across the world? That's exactly where ICT comes in, and that's what this video is about. We'll do this in 2 parts. First, we have the concept of ICT itself, 6 terms that build up one big definition, the same way we build into computer system last time. Then we have functions of ICT and 9 real sectors where the technology is already reshaping how things get done, with plenty of examples you will recognize. So let's start with the term you already recognized from previous. We have information. So information is processed data, facts that have been organized to something meaningful and useful to the person receiving them. We covered this in depth already. So here is just starting our block. Next, communication. In everyday language, communication is the exchange of information. In ICT specifically, it means the process of transmitting information or data signals from the source, which is the sender, to a destination, which is the receiver, through a transmission channel. Notice the 3 parts. We have the sender, we have the channel, and the receiver. So that structure repeats itself. Now telecommunication. So this word is actually built from 2 older languages, the Greek prefix tele and distant, meaning distant, and the Latin word communicare, meaning to share. So put them together, and telecommunication means conveying information or data from one device to another, where those devices are in different geographic locations using technological means. So the keyword is distance. That's what separates telecommunication from communication in general. So this leads us to a telecommunication system, which is a collection of compatible hardware and software arranged so that they can communicate information from one location to another. So every telecommunication system has 3 essential components. We have a transmitter, a receiver, and the transmission media connecting them. We shall talk about them when we reach networking. So think of a radio tower, your radio set, and airwaves between them. Next, information technology, or IT. So IT refers to all forms of technology used to create, process, store, retrieve, and exchange information in its various forms. Notice this is broader than just computers. So IT covers the whole life cycle of information. Now we put it all together. ICT, information and communication technology. So it is a term for any digital tool, system, or network used to find, store, process, and share information. But ICT, it's not just gadgets. It's technology plus the people operating it and being served by it. So in that context, we call people liveware. That includes both users of technology and the people providing the service. So a quick recap, in order, we have information becomes meaningful through processing. Communication is the exchange of that information between the sender to a receiver. So telecommunication adds distance to that exchange. A telecommunication system is the hardware and the software making that possible, built from a transmitter, receiver, and transmission media. So IT is the broader technology behind creating, storing, and exchanging information. And ICT brings all of that together with the people involved. So we have 6 terms, but one idea, just exactly how we build up to computer system previously. Now, practically, ICT isn't just a theory. It's already reshaping 9 major sectors of everyday life. So let's go through them one by one and notice how many of these you are already using without thinking about it. First, which is the obvious one, which is communication itself. So ICT lets us transmit text, visuals, and audio at very high speed through emails. We have live chats, we have online meeting, we have SMSs, the fax, which we don't use the fax nowadays. We have video conferencing. So every WhatsApp voice note you send to a friend in another town is this function in a second, commerce, which shows up in 2 ways. One, we have online shopping. So using digital money, we have credit cards or mobile money to order goods and services without leaving home. Thinking of ordering on Jumia and paying with M-Pesa. 2, we have advertising and marketing. So websites now let companies reach customers at a fraction of traditional advertising costs. We have YouTube running advertisements, inside videos is a textbook example. Third, we have entertainment. So across 4 areas, we have the music industry, so production and distribution of movies, production, editing, and streaming, like Netflix or Prime. We have computer games, production and distribution, and sharing and chatting through social media platforms like Facebook. We have Instagram, we have TikTok, we have X, which was originally known as Twitter. So almost your entire evening of screen time probably touches at least 2 of these. Fourth, we have banking. So electronic fund transfers, internet banking, mobile banking. We have ATMs, database management, and checks clearing are all automated now. So and customers get their SMS alerts on their account activity. So if you have ever sent money through M-Pesa or checked your balance through a banking app, you have used this function directly. Fifth, we have education. So in this, we have computer-aided instructions, which called the CAI. So it uses software to deliver interactive lessons and assessments. They are mostly used by young children. We have computer-aided learning, CAL, which has tutorials, simulations, educational games. So they usually have a paper-like display for basically for enhanced learning. And next we have computer assisted assessment, or CAA, where an optical mark reader scans a marked box or an ellipse on a multiple choice paper and scores it automatically. I think it is mostly used in the primary school sector for marking the multiple choice exams. We have online libraries where you can buy digital books. You can even order physical books. Yes, we have distance online learning, which most colleges and universities do. Um, Sixth, we have manufacturing and production. So systems like computer integrated manufacturing, computer aided design, and the computer aided engineering. So they all work together and are used to monitor and control production processes in factories, from the large vehicle assembly plants even to small manufacturers. So seventh, we have research. So the internet gives researchers fast access to journals, papers, learning materials. Even nowadays, we have AIs that lets them download the software they need, whether it's the software or the material. So the software example, we have the SPSS for statistical analysis is a common example. Digital payment even makes it possible to buy access to specific resources or online encyclopedias directly. So eighth, we have health. So across 4 areas, we have drug innovation and design, where information and biotechnology speed up diagnosis and treatment, knowledge enrichment through online refresher courses for doctors and pharmacists. We have automated fitness equipment in gyms and medical imaging equipment like MRI. We have X-rays and CT scanners used every day in hospital to diagnose complex conditions. We even have smartwatches developed to track things like your blood pressure, your heart rate, and you can access those that information on your mobile phone. So that is still part of this sector. And lastly, we have transport. So GPS lets companies track their entire fleet of vehicles in real time. We have the Doppler radar system, which helps aircraft detect and avoid storms. We have air ticket reservation, which can be done from anywhere in the world, and international flight. Ship and railway schedules are fully computerized. So every time you book a ride through an app or check a flight status online, you are seeing this function at work. So let's bring it all together. We have seen 9 sectors where ICT is applied. We have communication, commerce, entertainment, banking, in education, in manufacturing, research, health, and transport. So if you can take one thing from this video, so let it be this: ICT is what happens when computer systems stop working alone and start exchanging information, either with each other or with us. So next time we will go backward in time. We'll be covering the evolution of computers from the abacus, which were mere counting devices, all the way to the 5th generation machines, which is the AIs that we use today. So and the 5 generations that got us here. So I shall see you there.